Okay, great. Hi, everyone. Welcome to today's webinar, Dominate Texture Measurements. Presenting today is Martin Arndt, an application specialist at X-Rite Pantone. I'm Robert Grotan, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few things to go over before we get started today. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions, please use the questions function on the GoToWebinar panel. We will have time to answer some questions at the end. Finally, this webinar will be recorded and you will receive a link so that you can review the webinar at your convenience. So with that, I will turn it over to Martin to get things started.
Okay, so a warm welcome from my side. So like introduced, I'm Martin Arndt. I'm working as an application specialist for X-Rite Europe, and I'm based in Germany. And I would like to welcome you to our seminar, Dominate Texture Measurements, with the MAT6, 12, and also with the EFX QC software. So first, I'm giving you an overview about the topics. We would talk about the MAT models, differences, the MAT6 and MAT12, the features and benefits. We'll talk about the texture attributes and how to measure and communicate color, sparkle, coarseness, and also color variation, which is a new value available in our EFX QC software. And at least we talk about training workflow that I set up. It's an automotive workflow where you can have some deeper insights into the EFX QC software and how to analyze data within the software and the possibilities. First, the model overview. The MAT6 and MAT12 are two new multi-angle instruments from X-Rite. The MAT12 has two analyzers in the instrument, and the MAT6 has one analyzer, and the measurements fulfill the full set of ASTM geometries. New is also that we have a white LED illumination in the instrument, and this technology helps us even that there is no lamp change anymore required. We can work on an internal calibration process. The instrument has an internal white calibration tile, and an external calibration on a white tile and an effect tile is only necessary every 30 days. It's a high usability and the first multi-angle instrument that we have that can be operated by a touch screen. And within the texture measurement, there's a beam splitter at the 15-degree pickup that is going to get the data to an RGB HDR camera to characterize everything that is required for the texture measurement, so for sparkle and diffuse coarseness. We have a new design and an intuitive operation. So there's a direct measurement triggering feedback. We have this color touch display and a very, very intuitive menu structure that you see on the right-hand side. And we changed also the design of our previous instrument. We go back from this ring pressure sensor to release a measurement. You always know that you have to pressure firmly, which will also cause some damages and have user influence in measurements. So this is with this new pressure sensors that you can see on the display. We changed this by design that there is no more user influence within the measurement. So we got two contact points in the in-plane direction and one contact point in the out-of-plane direction in order to minimize tilt. And so there is a really new design with this, and it won't affect the user influence anymore. We have also one new feature. You can take a live preview at what you measure to avoid measuring scratches like you see it here in the snippet out window. So you got full control about what you measure. An indicator LED on the backside instrument of the instrument shows you in which operating status the instrument is. So green is when it's calculating or when it's ready to measure, and yellow during the process, and red if you make an error. Here's a short overview about the measurement geometries that we feature with the MAT6 instrument. So we have a 45 degrees pickups, and you can see all the lightnings or the lights that we have here. So we changed this by design as well compared to the MA98 series, where we had multiple pickups and one light source, and now we have multiple light sources and one pickup due to the more stable light conditions that we have with the LED light. At the MAT12 instrument, we have 6 more geometries. This is if you have samples, for example, if those were gonio appearance samples that change the color by illumination observation angles, then an MAT12 is required. And what is unique here is that we also have the ability to have texture values available for those angles who were behind the gloss, so the R15, AS-15, AS-30, and AS-45. It's the only instrument that covers texture measurement for these values on the market. Here's a short overview in a comparison about these two instruments. So the MAT6, which has 6 measurement angles, which were displayed over there in the section of the spectral measurement, and the MAT12, where you can see that we have 2 pickups, one at 45 and also one at 15 degree, and with the angles displayed over there. Down here you can see which angles were available for the texture measurement. You can see here, as I explained it in the graphics before, there are 6 angles available. This instrument features an RGB HDR camera to capture the images and to do the sparkle and coarseness measurements. We got 3 pressure sensors, and the aperture size is about 9 by 12 millimeters. Measurement time is around 4 seconds for the pure measurement and around 1.5 seconds for the calculation. And you see we have a very, very high repeatability on the Y tile of a delta E from 0.02, and also great reproducibility on BCRR tiles, which is an average delta E 2000 of 0.018. The texture attributes, which we see, measure, and where I go to take a look detailed, or go a little bit detailed more on it. So which texture attributes do we see in a metallic paint? So under the polar illumination in sunny sky, we can see the sparkle grade, and we can also see that we got color in the sparkles depending on which effect pigment we use. So mica or ceralic, where you see these colored sparkle spots. And under a diffuse illumination, an overcast sky, we can detect the coarseness. Regarding the values that will be displayed in the software and on the instrument, sparkle grade, so the higher the value is, the more sparkle effect is in the surface what you measure. And the new value, color variation, is the higher the value is, the more colorful the sparkles are. This is when it comes to a mica or ceralic pigment, where you see these green and blue, and also some pink, yellow, and red sparkle spots. And the higher this value gets, the more colorful the sparkles are. Coarseness, 0 is for really a solid paint, and 15 is for very coarse paints, only that you have an impression about the values and what you can what you receive by measuring panels like this. If you do a visual comparison of 3 similar samples, then you see under the direct angles, or here within the face angle, we see a gray. And It doesn't matter if it's an aluminum, silver dollar, or mica or ceramic. Mostly we see it looks similar. And you also see this under the different angles to the 80-degree angle or at the 15-degree angle, and even in the coarseness, they look similar. But what makes the difference? Aluminium silver dollar has got white sparkle spots, and ceramic has got colorful sparkle spots. As you can see it here, it's blue, green, and also a little bit of yellow and whatever is in this as a effect pigment. And most instruments on the market who have the capability to detect coarseness and sparkle grade, they will see just like this. So the coarseness is similar, and also the sparkle grade gives at least similar values. But in our instrument with the RGB camera, there is a chance to detect the color variation, which is how colorful the sparkle spots are. And there you can see that an aluminium silver dollar has a lower value of 4.32 compared to ceramic, which has nearly the double color value. And this is unique and new in our MAT instruments. In the EFX QC software, this is the software that we recommend for those instruments in order to analyze data. I set up a workflow that is just based on an automotive stuff that I made here. So you can create custom templates for each different application that you like to use. So this is a sample that I made where you can measure independently with the instrument on the car for quality control. So you build a template, load this to the instrument. You can measure your checkpoints that are required to control your quality, come back to the computer and receive the job and analyze the data. The good thing that we have here is that you could use custom images for schematic views. You can see the nice car over there on the right side. It's one that I personally prefer, a very nice one. You can see there's an ability to load in JPEG, PNG data, and whatever you require. Another good option that we have here is that we can combine checkpoint, and especially when it comes to areas where you need to have control of this. So here with a zero gap design between the bumper and the fender on the front side, there's an ability to have those checkpoints also combined and see what delta E those checkpoints have in between, not only compared to the standard. And the other thing that you see in the pop-out window in the middle is you can predefine metadata for the QA analysis, which means if you have some more facilities or production facilities, you can define where it's being produced, which side of the car you measured, in which shift was it made, what was the measurement point, and which production line was used to do this. So many things that you can set up, but this is just an exemplary style that I made and to give you an impression or just to see the possibilities that we have within this EFX QC software. Once you have measured your trials or your car in this case, you come back to the software, connect the instrument, and import the job. And after importing the job, you see I made it here with a vehicle information number, so the DNA of the car. I named this as a job name in order to identify my data. And once you get this here, you can also have on the first view, you can see if your color matches or a color matches not, or even does your texture data match or does your texture data does not match. You have an indication of green, yellow, and red. So very easy to understand for the operator. Then you want to analyze your data. You go a little bit deeper and you select from the left downside there the tolerance module that you wanted to apply to your view. So I selected here the Audi 2000, and then you can see that there are the delta values displayed. And here you can see also the value that I had here from this combined checkpoint. We had this single values that were displaying the delta E of the single points compared to the standard, and also the delta E between those two checkpoints that were displayed here at the end. Here you can easily see that there is a problem with the mirror housing where we receive a very, very high delta E on color. So there must be something wrong during the production process. And you remember that we have one checkpoint that was yellow. So switching to another tolerance that I applied to this standard is a sparkle grade tolerance. And there you can see at the front door, yeah, it gets to a margin of a sparkle gate tolerance that I set to a level of 1. You can see, oh, it gets to, yeah, some differences and some problems that we could achieve at the front door. You see there the margin marking. So this is everything you see just by 2 clicks when you import the job. Going deeper into that is that you can change from the schematic view to the overview table, and then you have all the delta values for the data that you pre-select. They're available. You can select all angles. You can select only the 45-degree angle, whatever you require to get a quick overview over your data. In order to dive deeper into the settings, you can choose the job detail view, which is the second navigation from the top. And there you can also select the angles that you wanted to see and display. There you have the LAB delta data and also the delta data. You can also display the LCH data if you wanted to require, but I don't want to blow up the screen that much in these cases. On the right-hand side, you have LAB plots that you can display. We can display up to 9 LAB plots within the software. And there you can also see that we have a colored indication of what we're just looking at. And you get an easy overview. So what might be the problem? So in this case here at the mirror, it's the angle which is near to the gloss, which is always causing trouble. And yeah, also the one that's behind the gloss. Going a little bit deeper into the analysis is switching here to the color trend. So moving from the LAB plot to the color trend, you have multiple trend charts that you can display. So in this case, I displayed the tolerance trend for delta E 2000, and I can also display LAB or LCH trends if required or what I wanted to take a look at. In the next step, you move from the job detail view to the spectral data. You can display the spectral data for all the measurements that you have. You can select the angles that you wanted to display. And the nice thing in this view is, and in some different views as well, you can just easily select the data and do a right click and export it to each party software that you require as a CSV or even to Excel directly. So it's a very nice feature that we have in here. Within the flop index, you can also control what was the flop index of my standard that I measure, and also the absolute values that you have in your checkpoints that you measured. And you can also have the delta values here of the flop available in this view. In the next section, the texture, we can have the view to all the texture data that we have. You can see here on the left-hand side, we got the color variation of the standard, we got the coarseness value, and we got also the sparkle grade of the standard that it's been displayed here on the left-hand side. And then we can walk through the values and the differences that we have had with our checkpoints that we measure. So the differences within the color variation. So you see the absolute value in the next column, and the delta values were then displayed on the right-hand side of these views. And there you can see what differences occur. And you can easily detect here that there was at the front door where we have this margin that there was the most stuff coming from the sparkle grade, but we got also bigger differences within the color variation. And we will dive a little bit deeper in the analysis and see where those stuff was coming from. Down there, you can display multiple trends for the texture values as well, for color variation, coarseness, and for sparkle grade as well. To go in the deep data analysis, there is the single trial view. For the single trial view, you select from the navigation panel on the left side the single trial. In this case, I selected the mirror housing, which you wanted to investigate and see what's going on there. On the right-hand side, you see there's a single LAB plot then available where pass and fail informations were directly displayed. You will have the standard data on top available, and on the bottom, you have the LAB data or LCH data, depends on what you wanted to display, of your single trial or the checkpoint that you just measured. Right beside, you see the delta values, and on the end of this, also the delta E2000 values. Down on the bottom of the navigation panel, you have a rendered view of how the color looks like. So you can compare there a little bit visually against your standard if there was something maybe going completely wrong. Within the spectral data view, we see that the first time our spectral curves. The dotted line is for the standard, and the complete line is for the checkpoint or the trial that you measured, where you can compare those, and you can also export it from here, the data, if you would like to another third-party software. Within the flop index, the same data, but here with the texture, there it gets to the big benefit that we have with the HDR camera in the instrument. We can compare here the image of the standard panel against what we've measured within our checkpoints or our trials. And here you can directly see, is there a change in between these two? So did I measure the right thing? How is the flake orientation? It can also give you some indications if you have differences in thickness where the flake orientation might be different. And you can walk through all the angles here. You see that there are 7 angles available where you can have texture images. You can see this is the -30 where I would just move to, and you can directly compare on the downside the image of the standard compared to the trial or to the checkpoint that I just measure. And you have also the data, the texture data for color variation, sparkle grade, and coarseness available on top of the screen. You can see here at the front door, it's always when it gets a little bit more to the angle of 15 AS80, it's getting very dark and you mostly don't see that much anymore. But all these angles were available to watch single images, and as well you can watch images for the coarseness. So everything here now is under control, and the good thing about it is we can also select or bring those images into our report function into Excel, which is available on the top left side. So below the file menu, you can just export it into an Excel file for reporting purposes, and you will have those data. If you take this texture images also available in your report, which makes it easier for people who were not having the EFX QC on their computer to evaluate those data as well. That's from my side, a quick overview. and I would hand over to Robert if there were some questions currently occurring.
Yes, thank you, Martin. If you do have a question that you'd like to ask, we have a few minutes here left. Feel free to submit one now. While we wait to see if any questions come in, I am going to launch another polling question if you are interested in talking to someone. All right, it looks like we have a question coming in. What is the spot size on the MA6 and 12?
So the spot size, you mean the size of the measurement. So the measurement area that we have, it's 9 by 12 millimeter. You will find this in the section of the technical data. Does it answer your question?
Another question here is, what does 45 AS15 mean for angle?
It's 45 AS15. Did I get it right?
Yes.
I would say long word to this is aspecular 15. So which means this is calculated from the gloss angle. So it's 15 degrees from the direct gloss angle. So 45 is the pickup, and the gloss will then go into this 90-degree direction. So I could quickly jump over there. You can see it's 15 degrees from the gloss over here. That's just the definition of the angles here that you see. It's beginning to count from the gloss angle of the pickup.
Perfect. Looks like we're just about approaching our time, so we will end there, and I'm not seeing any more questions. If you do have a question, feel free to reach out to us, and I can certainly direct them over to Martin. Again, a recording for this session will go out tomorrow, so thanks everyone for joining, and have a great rest of your day.